All right, hello people going to TVC Band. Here we go. This is chapter 7 review. We're going to start this today. We got 3 to graph, and then we've got a couple that we're going to do. We're going to try to get through the majority of the front page, at least to like number 9, I think, hopefully.
No, you said 6.
We'll see. We'll see. We'll see how far we get. But then we have to do stuff tomorrow.
It's a Monday.
So this is the schedule. This is what I have scheduled for this week. Today, tomorrow, we're doing chapter review. On Wednesday, we're going to do some whiteboards and then test on Thursday, right?
Ew.
So, like, the more we get done, the more time we have for whiteboards, which is, like, the part that really helps you.
No.
I don't know. We'll see, okay? Here's what I want you to make sure. You check really quick. Your blue sheet, which is your unit circle, grab that, take that out, and make sure that on the back side of it, you have sine, cosine, and tangent graph. You get to use this on your test. Yeah?
Awesome.
Okay, if you do not have sine, cosine, and tangent graphs on the back of your unit circles, you need to do that, okay? We graphed it together, but if you didn't write it down, you need to make sure you have it written down, all right? Sine, graph each function, and they're wanting us to graph it over the interval from -3 pi to 3 pi, okay? Normally, sine goes from 0 to 2 pi, all right? So I'm gonna put 2 pi here, but then we've got to go out to 3 pi. So I'm gonna first graph them from 0 to 2 pi, because that's how I know how to do. And then we're going to go out to 3 pi and we're going to continue on, all right? So, there's 0 to 2 pi. How high up does he go? Normal sine, the sine of t.
1.
He goes up to 1, down to -1. All right, does he start in the middle or start at pi?
Middle.
Middle. He goes middle, up, middle, down, middle. And this is what he looks like just from 0 to 2 pi, okay? Now, if I'm going instead to 3 pi, which would be here, he does how much more of a cycle?
Oh, shoot, gets half.
Half, right? He does another little hump up at the top, right? Just from there to there. Do you see that?
Mm-hmm.
That's just a 3 pi. Okay? Then we're going to do the same thing on the other side. So I'm going to do -pi, -2 pi, -3 pi. Okay? And I'm going to go here, here, here. If you want to put your dots into place, that's fine. I'm going to go down, middle, up, middle, down, middle, and he curves like this. So it's like exactly the same on the other side, but just flipped. So you should have 3 high humps and 3 low humps, right? No more than that. 3 high humps, 3 low humps.
I did something
Okay.
backwards. What did I do backwards? What?
All right, now, how far apart is -3 pi and +3 pi?
That's a good question.
How far apart is -3 pi and +3 pi?
6 pi.
6 pi, okay? How wide is one period of
2
sine?
pi.
2 pi. If I divide by 2 pi, how many cycles should he have done?
3.
3, right? Do you see the 3
1,
cycles?
2,
Here's one
3.
chunk. Copy, paste, copy, paste. There's 3 chunks, right?
Yep.
Okay, so you can kind of verify how this goes. That is what the sine graph looks like. Got it? Okay, between -3 pi and +3 pi. Normally we only graph from 0 to 2 pi. Okay? Done with that? Graphing cosine? Cosine, same thing. -3 pi to +3 pi. I'm going to go just from 0 to 2 pi real quick. 2 pi. I've got pi. I've got the middle in the middle. Okay? And he goes up to 1, down to -1. Does he start in the middle or start at pi? Cosine.
A pi.
Cosine. Starts at
0.
pi. He starts at pi. And then he goes down, and then down, and then middle, and then up. And then he does one of these. And just like that. Okay? All right. I want to go out to those 3 pi. So I'm going to put a little tick mark there, and I'm going to go 3 pi. And he should go just another little portion of it. So instead of going high, he'll go middle and low, and he'll go like this, right? So he'll be another little half cycle there, right?
Mm-hmm.
And then I'm going to do the same thing, but on the other side. So I have -pi, -2 pi, -3 pi, and I got my little tick marks in the middle, which I'm not going to mark. So I'm here, I gotta go middle, down, middle, up, middle, down. I just keep doing that until I run out of space and connect the dots. Okay, that is what cosine is. How far apart is -3 pi and +3 pi? 6 pi. So how many cycles should he have made?
2, 3.
3, right? Here's 1. Copy, paste. Copy, paste. There's 3 of them, right? They look exactly the same. Got it?
Mm-hmm.
That's cosine. That was really fast. Are we going too fast? Are we doing okay?
No, we're not.
All right, at least have that much marked, right?
Okay.
Okay, I mean, some of our drawings are really icky, but at least have your amplitude marked and have like these markings here, okay? That's what I'm gonna judge to make sure that you have it right, okay? Good?
Yeah.
All right, tangent now. All right, tangent splits the middle, and he has a vertical asymptote here, and he has a vertical asymptote here. Where are those located?
Pi over 2.
Pi over 2's, right? So I have pi over 2 and negative pi over 2, right? Got it? And then he does one of these, whoop, and he does one of these, and that's what tangent looks like. Okay, except they want me to go from negative 3 pi over 2 to positive 3 pi over 2, right? And he always has his vertical asymptotes on the twosies, right? So like the next spot over here where his vertical asymptote would be is at
2 pi. Wait, no. 3 pi over
3 pi over 2, right? 3 pi over 2 would be there. Okay? And he has another vertical asymptote over here at negative 3 pi over 2. Hey, that works out nice. So then all I have to do is put my little dot in the middle and go up and go down. And put my dot in the middle and go up and go down. Okay? Alright, 3 pi over 2 is 1.5 pi. So we're going from like negative 1.5 pi to positive 1.5 pi. How wide is that? 3 pi wide. What is the period for tangent? How wide is tangent normally? Pi. So how many cycles should he have do in 3 pi? Is he doing 3
Yes.
cycles? Yes. Does that make sense? Okay. Got it? That's tangent. Tangent. Happy with that? Okay, make sure you have those graphed on your unit circle, at least one cycle. You don't have to have like the 3 cycles that we did, but at least one cycle. Got it? Okay, now we get to maybe the confusing part-ish.
I don't remember those.
Okay, they say find the exact values when sine is negative 1. Okay, so let's go up to the sine graph. Let's just look at him. Where is he touching negative 1? Right here. That's negative 1, right? And right here, he's negative 1. And right here, he's negative 1, right? So let's just pick one of those spots, right? Let's pick this one right here. Sure, it doesn't matter which one you pick. Let's pick this one. What is this coordinate right here? Like, where is he located at? This is pi, and this is 2 pi. 3 pi over 2 is where he's located, right? 3 pi over 2. Okay, now, so he is touching negative 1 at 3 pi over 2. But how often later or how often before is he going to touch? Like, when does he touch before? Or before? Like, how far apart are those? How far apart are those?
Pi over 2. Or like pi over 2.
What's the period of sine?
It is 2 pi.
2 pi, right? 2 pi before, every 2 pi after that, right? He's going to touch in that same spot. Does that make sense? The cycle is 2 pi. So, what do we put for here? 3 pi over 2 is where he's touching it maybe the first time, right? But then we do plus or minus
Oh.
Plus minus pi x.
2 pi
2
x
pi.
or whatever, 2 pi x. So every interval of 2 pi before or after 3 pi over 2, he's going to touch at negative 1. Does that make sense?
Yeah.
Yeah.
I guess.
All right. Okay, this one you're going to have to use your unit circle for, kind of. Ish. Okay? Tangent is the square root of 3. Okay, the square root of 3 as a decimal is like 1.4 or something like that, right? So it's saying, where is tangent touching 1.4? Like tangent 1.4. 1 is here, 1.4 would be like here, right? So he's going to touch right there, and he's going to touch right there, and he's going to touch right there, right? All right, if you look on your unit circle, really fast. Where in like the first or second quadrant does tangent touch or equal the square root of 3? I want this to be the square root of 3.
Pi over 3.
Square root of 3. Is it pi over 3?
Yeah.
Okay, so what they're saying is that this dot right here is equal to pi over 3. Right? That's where that dot is. Got it? Pi over 3 is where the square root of 3 is. Okay? So the first place he touches is at pi over 3. Pi over 3. And
Plus minus
how far later will he touch again?
pi.
Pi. Why pi and not 2 pi?
Because.
because tangent's period is pi, not 2 pi, right?
Mhm.
So before or after that, it would just be plus and minus pi x or pi k or whatever variable you want to use. Does that make sense?
No,
Pi over 3 is where he's touching at the square root of 3. You can see that in your unit circle.
but also at 4 square root of 3. Or
Right,
5.
but
What?
pi over 3 plus another pi would cover my 4 pi over 3.
Mm-mm.
True?
Mm-mm.
Yeah, huh?
That's bogus.
Okay. All right, let's go to the cosine graph. Square root of 2 over 2. Somebody find me the decimal of the square root of 2 over 2. What is that?
1.25. Actually, no.
No, it's like 1.41 is the square root of 2, so 0.705.
0.707, I think is what it is.
Or 75.
0.707.
So you knew it, but you still wanted that.
Yeah, I had to think. For a second. 0.707 is what the square root of 2 over 2 is. Okay?
I'm thinking
So we're trying to find where the cosine graph touches the square root of 2 over 2. That's not quite at 1. 1 is up here, okay? So he's going to touch 0.707 like right here. He touches right there. He touches right here. He touches right here. He touches right here. He touches right here. He touches a lots of places.
Yeah.
Right? Okay? So let's just look at this chunk right here. Boop. And boop. That's the first chunk of cosine, right? Like that's from 0 to 2 pi. He is touching at this place. Okay? Where is cosine the square root of 2 over 2? What is that place at? Square root of 2 over 2 is at, where'd you say? Look under your
I
circle.
said pi over 4.
Pi over 4. So this dot right here is at pi over 4. Do you see that?
Mm-hmm.
But cosine has a second place that he's touching,
Which is 7 pi over 4.
which is 7 pi over 4. That's this guy, right?
Mhm.
Now, if I start with pi over 4, which is this guy, and I add 2 pi to it, that will give me this one right here, right? Like the same spot. And if I add 2 pi to this guy, it will give me that same spot in the next spot, right?
Mhm.
Or like this one's gonna give me this one, and this one's gonna give me this one, and this one's gonna give me this one, right? Like that's how he works.
Yeah.
So in this one, I have 2 places where he's touching at square root of 2 over 2. Does that make sense?
Mhm.
And they are first at pi over 4 and second at 7 pi over 4.
Okay.
But I do plus and minus how much?
2 pi.
2 pi x and 2 pi x, right?
Ew.
Because in that first little chunk, he's touching it twice, I have to list both of them. Does that make sense?
I don't like domain and range.
Yeah. I think I like domain and range better than I like those ones.
I don't know.
3, 4, 6, 3,
Since
4,
you
5.
told us to look at the thing, it's
Yeah,
not that hard.
yeah, it's not
Once
too
you
bad.
tell us to look at,
Once you look at the
Would
unit
you-
circle, it's not too bad. Okay, domain and range of tangent of 2t. Okay, what does the 2 do to him?
Stretches.
no, it's his.
It's the
amplitude.
period,
Oh,
right?
what?
Okay, it
Oh.
changes the period. Okay, how do I calculate period for tangent?
Pi over b.
Pi over b, right?
Pi
So,
over 2.
tangent's period would now be pi over 2. What's tangent's normal period?
Pi.
Just pi. Normal
Done.
is just pi, yeah? Okay? Alright, so when I graph tangent, I'm going to do a little rough sketch of him, okay? When I graph tangent, normally his period is pi.
Easy.
So he
It's
goes from
Too easy.
negative pi over 2 to positive pi over 2, right? But if his period is pi over 2, that means from here to here, that's a distance of pi over 2. What's he going to go from here to here? What's his vertical asymptote's going to be at? If he's pi over 2 wide, how much does he go the one direction? How much does he go the other direction?
5 or 4.
Pi over 4. So negative pi over 4 and positive pi over 4, right? That's where his vertical asymptotes will be. Okay? And then he'll do like one of these, right? One of those. Okay, domain. Let's talk about domain and range. Which one is going to be all reals?
Domain.
Domain. Range.
Range.
Up and down. He's going to go up and
Oh.
down forever, right? So range is going to be all reals. Okay, domain. Is he going to touch everything left and right?
Nope.
No.
Except the vertical asymptotes.
Negative pi over
So
4
x
to
is
pi over
not going to be touching
Negative pi over 4 plus minus.
at negative pi over 4 plus minus. When is his next
Pi over
vertical
2x.
asymptote?
Pi over 2x.
Pi over 2x, because he has, now his period is pi over 2, right? So every interval of pi over 2 after that is going to be a vertical asymptote. Does that make sense? Now, could you have just done positive pi over 4 and plus minus pi over 2?
Sure, you can do
Sure,
it.
because it's going to give you the same thing, right? So you can either start at this one or start at this one. Woo! Okay, got it? This is gonna be tricky. Alright, happy with that?
Mm-hmm.
Alright, transformations that change this thing. List the transformations that change. If you want to, just go ahead and list out the amplitude, period, phase shift, vertical shift. That is totally fine. I will accept that for the list the transformations, whatever.
Amps 5.
Amp is 5. What's the 4 do?
Vertical stretch.
Vertical shift.
Shift by
Down,
down
4. What's the period?
One.
No, nothing. Or 1.
No, it'd
No.
be 1.
B is 1, which means the period is
2 pi.
2 pi still, right? It'll stay at 2 pi. Phase shift?
Nothing.
Left and right? Nothing. Okay, so really the only thing that's happening to it is you're making him 5 units tall and you're shifting him down 4. So if you want to describe it like this, if that helps, do that. Okay?
How do you
Okay.
find,
Number 9 is the same thing.
how do you find phase shift?
Negative C over B. So there's no phase shift here because there's no like parentheses, whatever, and then minus 4. That makes sense? That's why he would have to have that little thing there. Okay? Alright, let's do, we can get through 10 maybe.
Sure.
9 is doing
Just get
the
the
same
just
thing.
get the front page done.
Sure, let's do it. Amplitude,
Negative.
period, phase shift, vertical shift.
Flip over X.
And flipped, yeah, so we have to list that as well. So he is flipped, we've taken care of that. What's the amplitude?
One.
Negative 1.
1.
Just
Well,
one.
Just 1, right? What's the 5 do?
Goes up.
Up 5, vertical shift, up 5, okay? Now this 2, that is the B value, and that tells me
B
the
over
period.
2.
Now here's the deal though.
What?
When we're doing period, we
What?
either do 2 pi over B or pi over B. Which one do we use for cosecant?
Pi over B.
Or no, 2 pi. It's always 2 pi because it's.
How many ounces is it?
Which one do you use just pi for?
Tangent and
Maybe we'll write that off to the side over here. So 2 pi is the period versus just pi is the period.
No.
Period.
36.
And period.
32.
That's halfway off.
The only one that has a period of pi is tangent and cotangent. Otherwise sine and cosine and secant and cosecant.
How much was it?
50.
What? I should put it in order. Cosecant and secant. These two go together, these two go together. Those are all 2 pi's.
Can you
Got it?
write this down on our blue sheet?
It's bull crap. It's
What?
bull
If
crap.
you want to, sure.
I found an unbranded one for
Yeah.
like $12.
Erica just asked, can we write this down on our blue sheet? I don't care. Sure. That sounds
You
good.
can put whatever you
You
like.
can put whatever you want on your little blue sheet.
But mine has a handle.
Can we put the whole review on our blue sheet?
I may let you use your review on your test actually.
Claire,
That'd
you
be
don't
nice.
need
That'd
to.
actually-
I'm already done with the review.
You know what? But you
I was
figured
done
out
over 5 minutes.
Alright,
I
so
was
real
done
quick.
7 minutes ago.
good for you.
So period, we have our B value is 2, right? So I take 2 pi and divide by B. So what's the new period?
We can engrave already.
Pi is the new period. So period is pi now instead. Okay? Alright, phase shift.
There is none.
There is none. There's no C value, right? Okay?
I don't
Phase
like, I
shift.
don't like talking.
I like
I like.
Alright, last one. You want to try number 10 real quick? I'll give you a couple seconds and then we'll do it together. Okay, try number 10 on your own.
Would hurt more.
So something, cosine, something, t, something, and then something. Okay, figure out where those numbers go. I'll give you a couple seconds. We'll get them figured out.
I asked
Okay.
Carter too.
Put the numbers where they go. At least get the first and the last one right, right? Those ones you should. Ooh.
We did quality bench. I didn't want to go crazy today.
She did quad bench.
Yeah. But we didn't finish bench. So
Period is the.
I'm just gonna tell my old
So you do
maths.
2 pi over b to find the period. So 2
Okay.
pi over b
I
equals.
forgot what number to say, so I
4
was
pi.
like 220, 265. And she goes, did you actually do that? I'm like, a couple months ago. She's like, oh, I'll see you again tomorrow.
Your squat's only 265.
Bench.
Oh. That's why I deadlifted today.
Alec was deadlifting 225, and I'm like, I thought you were kidding me. I was like, let's get it. It's like a deadlift.
Did you get them figured out? Are we ready?
Yep.
Okay, what's your first number?
4.
4. What's your last number?
6.
Plus 6. Okay, that should be easy. All right, so those are done. Boop, boop. Okay, the period. How do you find period? 2 pi over b, and that's equal to 4 pi. All right, how would you like to solve for b? If b is in the bottom,
I'm looking at my multiply this, like, so.
let's just flip these two, right? Can we do that? So 2 pi over 4 pi equals b.
Get new brakes, new rotors.
The pi's cancel. What's 2 over 4?
That's 15 right
1 half. That goes
Paid for it.
here.
Yeah.
Okay?
No.
All right, now next.
It's not like I would.
We have to do the phase shift. How do you find phase shift? Negative c over b, and that's equal to, what do we want negative c over b to be?
Pi.
Pi. We want that to be equal to pi. Okay, so b we know though is 1 half. Let me put that in a different color. 1 half. So how do I get c by itself?
Multiply by 2 over.
Hold on.
I think
Alright,
it's like-
what? You said how do we get
I
C by
knew you were
itself?
gonna do that. I'm glad you did.
No, okay.
If we keep flipping to the top, you would multiply by 2.
Five.
We're multiplying him, Kyle, to the other side. So we're gonna multiply by 1 half still. You're not keep flipping him because we're not moving him to the top, we're moving him to the other side.
That way it's
Does that make sense?
Oh, yeah.
So c will be equal to half pi, which is pi over 2, but also
It's negative.
it's negative because the negative goes with him over to this side. So negative pi over 2.
Do that.
Yeah?
That's kind of like messed up.
Questions
I
about
usually
that?
pay for, like, everything.
So, do you understand why it's not keep flip flip?
She paid for my
Yes.
gas.
Okay, because you're moving to the other side.
I'll pay for
All right, tomorrow we'll work on the back side.
something.
Okay? Good? All right, that was really fast. Goodbye, people watching this.